Okay, so in this last example that I'm going to do for this section, we're going to use it finding acceleration. So we're dealing with a particle moving in the x direction along the x-axis. So it says the position of a particle along the coordinate axis at time t, okay, in seconds, is given by s of t equals 3t squared minus 4t plus 1. So this is the position function, s of t. 3t squared minus 4t plus 1. And that's in meters, okay? So this is meters, and time is in seconds. So this is meters per second. Okay? Now, find the function that describes its acceleration at time t. So instantaneous acceleration, okay? So now realize that v of t is equal to s prime of t, right? The first derivative of the function. Acceleration at time t is given by the first derivative of the velocity function, which is equal to the second derivative of the position function. Okay? So, what we're going to do is we're going to have to take the derivative twice. Okay? So let's do it. Okay, so we're going to find what? Velocity first, which is equal to s of t, which is equal to the limit as t approaches, hold on a second. Oh, h. Is it t? No, h. Just confusing myself. H approaches 0 of, now what we're going to do is it's going to be s of t plus h minus s of t over h. Okay. So now all we're going to do is now simplify. So limit as h approaches 0, this is going to be 3 times t plus h squared minus 4 times t plus h plus 1. And then we're going to subtract off s of t. So we're going to subtract this off. So I'm going to write this parenthetically. So I'm going to write this a little weird, so sorry. So 3t squared minus 4t plus 1. Sorry, I'm running out of room here. Over h. Okay, now I'm going to simplify this. So again, be careful. Make sure you're doing this on your own. See if you get the right answer. But again, just be careful when you expand this out and make sure everything cancels that's supposed to cancel. Okay, so this is going to give me the limit as h approaches 0. Now this is going to give me, this is going to be pretty long, 3t squared plus, oops, 6ht plus 3h squared minus 4t minus 4h plus 1, don't want to forget the plus 1 this time, minus 3t squared plus 4t minus 1. That's important because that is what's going to help us cancel everything that needs to cancel. So now, the 3t squared cancels with the 3t squared here. 3t squared minus 3t squared is 0. And then we have what? We have minus 4t plus 4t. Those are going to cancel. We have plus 1 minus 1. Those are going to cancel. Now everything else has an h in it, and nothing else can be combined. So now it's going to be the limit as h approaches 0 of 6ht plus 3h squared minus 4h. And that's it. And now we're going to factor out h on top, so that's the limit as h approaches 0. H times, and what's left over is 6t minus, hold on, yeah, that's right. Okay. Sorry. I was just, so 6t minus 4. Forgot I was factoring out the h. So 6t minus 4 plus 3h over h. So now these are going to cancel. And I get the limit of this thing as h approaches 0. So this is going to go to 0, which is going to leave me 6t minus 4. So that's going to be the function for velocity. That's going to be the velocity function. So now what I have to do is do it again to get the acceleration function. Okay? So now I'm going to start over with 6t minus 4. So I found the velocity, oh here. So I found this is 6t minus 4. Okay, so I found that. Now I'm going to find acceleration, which is now the derivative of the velocity function, or the second derivative of the position function. So now I'm going to do the limit as h approaches 0 using this function now. So now it's going to be what? It's going to be v of t, v of t plus h minus v of t over h. Now, so that's just one way I could have written it. Okay, so now this is equal to the limit as h approaches 0. And this is going to be what? It's going to be now this, which is 6 times t plus h minus 4 minus 6t minus 4 over h. And so this equals the limit as h approaches 0 of now what? This is going to be 6t plus 6h minus 4 minus 6t plus 4 over h. And now look what happens. 6t minus 6t cancel. Minus 4 plus 4 cancel. And I end up with the limit as h approaches infinity of 6h over h, which equals 6. And so the acceleration of the particle, now, what are the units? The units are meters, the position function is meters, the velocity function is meters per second. The acceleration is meters per second squared. So this is 6 meters per second squared. So again, when you're dealing with an application problem, you must use the contents of the problem, the context, right, which means units. If units are given, you want to make sure that you use units in your answer. So me personally, if I don't see units, if it's an application problem like this, I would expect that you would know to write 6 meters per second squared. And then also if I was asking for the velocity, then this would be in meters per second. Okay? So, and then of course the position function is in meters. Okay, that's it. Have a great day.